Hello students, this class also we are going to discuss the problems in electrostatics basing on electric field and force concept. So today top problem we are going to take basing on oscillations related to concept of force. So here in this case, first if you consider the question, two identical positive charges given, that is capital Q. There are two charges are given, so I'm taking a line here to explain this one. This is the one of the line. So on this line we've taken two charges here. So these two charges having capital Q, one is capital Q, second one also capital Q, are fixed at a distance of 2a. The separation between these two charges equal to how much? That is 2a. This is given in the question. And apart from each other, another point charge Q naught, another point charge is Q naught of mass m. So we taken one more charge of charge Q naught and mass m is placed midpoint between the two fixed charges. These are the two fixed charges. We taken that another charge. The charge is Q naught having mass m. We kept exactly middle. Middle means the distance of the Q naught from the one of the charges, any one of the charges A. Now, for a small displacement along the line joining of the fixed charges, this is the line joining of the two fixed charges. So there is a force of repulsion between the two charges will take place along this line joining. So what we are doing is this Q naught, we are displacing a small distance of x. That means we are changing its position from here to here. Now, what is the distance of displacement? That displacement is you take as x. That is a concept is given. Then the charge Q naught executes the SHM. That means in this case the concept you need to understand before only. So whenever the charge is displaced between the two similar charges, it will execute the harmonic motion. Either it may be simple harmonic, it may be harmonic according to the condition of the displacement. So here whenever it is displaced, it is performs the oscillation along this line. So they're asking to calculate the time period of oscillation of this Q naught. So here first to solve this one, what is the initial condition of the Q naught? This is the initial condition. Now where we are displacing, this is where we displaced. When it is displaced at this position from the one of the charge, what is the distance of this one? The distance of this one, total length from here to here is A. Now after changing its position, now this distance in terms of A I can write as A minus X. So this is the distance between the charge Q naught and Q. If you are having any trouble in understanding, you can take in red color. So this is the charge Q naught. Now it is due to this position at a distance of A minus X from the first charge, and from the second charge, from here to here how much distance? That is A, and from here to here how much? That is X. Totally the distance is A plus X. So one charge is at a distance of A minus X, second charge is at a distance of A plus X. So both are different distance, but both are repulse each other in opposite direction. So due to that, what happens? It performs oscillation along the line joining between these two charges. So to explain the derivation of this one, first you have to understand net force, because any particle which is oscillating having acceleration, that acceleration is due to one of the force. If the number of force are acting, net force you have to take. In this case, two capital Q charges repulse this Q naught. That's why there are two forces are there. So both combination we have to take the net force. The net force gives the concept of oscillation. So net force equal to, according to the concept of oscillation, mass into acceleration. That is nothing but m into, we can write as omega square x. And also we can write this one in terms of time period also later. But this F net is equal to, in terms of charge based, two forces are there. One is this Q repel this one in this direction. So that force you take it as F1. This Q also repel this one in this direction, that you take it as F2. Which is more? The A minus X distant charge is near, so repulsion will be more. So I can write F1 is more than F2, so F1 minus F2. So what is the F1 formula? If you take on the F1 formula, that F1 formula I can write as K, nothing but 1 by 4 pi epsilon naught. I am writing as K into capital Q small q naught by square of the distance between them, that is A minus X whole square, minus second force due to second charge, that is K into Q naught by capital Q small q naught by distance. What is the distance? A plus X whole square. Now we have to solve this one to get the relation. So here F net is equal to what I can write? that is m omega square x is equal to, directly I'm writing to reduce the number of steps of solution here. You take LCM of this one, it is a minus b, a plus b. So if you take an LCM of this one, what I can write here, a minus x whole square into a plus x whole square if you take an LCM of this one, and k capital Q small q naught if you take an common. So remaining what I can write, that is I can write as a plus x whole square minus a minus x whole square after taking LCM. Now you have to solve this one. If you solve this one, what I can write, k capital Q small q naught into, in bracket term, this is in the form of a plus b whole square. You can expand it. A plus b whole square means this is nothing but a square plus x square plus 2ax you'll get, minus this is a square minus x square and minus of minus plus 2ax you'll get, and divided by, this is in the form of a minus b into a plus b. I can write as a square minus x square whole square. A plus b into a minus b is a square minus b square, that is whole square. Now in this case I can cancel this plus a square minus a square plus x square minus x square cancel. So I can write m omega square x equal to, how much you are going to get, k capital Q small q naught into 4ax by, that is in the denominator a square minus x square, a square minus x square whole square here. So here the condition of the question, if you observe this one, in this case the charge q naught is executing in this case. So if you see the, okay, another charge q naught with the mass m fixed between two charges. In this case small displacement is given. Small means compared to distance between the two charges A, the x value is very small. The x value very small means you can take this one value almost 0. If you taken that 0, k into capital Q small q naught 4ax by, you will get, that is a power 4 you get, because x value 0, this total will become 0, a square whole square means a power 4. So 1a get cancelled, that is a cube we are going to get. So I can write this one, k capital Q q naught, that is 4x by a cube. So in this case, according to SHM, this is mr omega square, that force, this x get cancelled. Now I can write omega square formula. Omega square is equal to m mega that side. It becomes k capital Q small q naught into 4 by m into a. This is one relation we'll get, right? Next, if you write this, what is omega from this? Omega is equal to under root of, we are going to get, that is k q naught, sorry, k q into q naught into 4 by m a cube. Now what is omega? The omega is equal to nothing but, you are going to get as 2 pi by t. So that I can write as 2 pi by t is equal to, I can write as under root of, that is k q naught 4 by m a cube. So from this time period of, okay, oscillation, what I can write, time period t is equal to, I can write as 2 pi. The 2 pi you make it inside the root so that it will becomes 4 pi square. If you taken this one inside the root, it becomes 4 pi square. So I am writing in a single root, that is 4 pi square into m a cube already in the root by k value. K value is 1 by 4 pi epsilon naught into capital Q small q naught into 4. So what are the things you can cancel? You can cancel it here. This 4 we can cancel, and we can't cancel anything. So in this case, this 4 pi epsilon naught, I can make it to the denominator. You bring it to the denominator. If you bring it to the denominator, what the equation you are going to get? T is equal to, that is nothing but under root of, so denominator 4 pi epsilon naught we are making up. So already, okay, there is a pi square is there. So 4 pi cube epsilon naught into m a cube by, that is capital Q into small q naught. Remaining everything is cancelled if you observe the derivation of this one. So which is near to the observation? First option, if you see this 4 pi cube epsilon naught m a cube by capital Q into small q naught. So option A is Now this question is given in the previous one of the mains question. So you can see this. A uniform electric field is given 8 m by E value is given in terms of volt per meter. We'll understand the unit of this one is created between the two parallel plate of length 1 meter. See, two parallel plates are there separated by distance of what is the length of this one? 1 meter. And in between we apply the electric field. The electric field, if you observe this one, this is the way direction of the electric field is taking place, plus to minus. And there is electron is there, that electron having charge E, this electron which is enters into this the field symmetrically between the plates with a speed 2 meter per second. That means it is entering with a speed of already given in the diagram very clearly 2 meter per second. Now the angle of deviation of the path of the electron as it comes out of the field will be, what angle will comes out? This theta is equal to how much they're asking. First here, three concepts you need to understand here. First one, whenever any charge enters into the electric field, what happens? It experiences a force. Due to that force, what is the path of the charge? The path of the charge always, whenever the charge enters into any electric field, the path of the charge always parabolic path. So you can apply the parabolic equations to solve the problem. One. Next, this is the first concept, that means here it experiences a force. Experiences a force, first concept. Second concept, what is the second concept in this? In this, it is traveling in between the two plates. While traveling, it is traveling some length, that is nothing but called as distance it is traveling, and it is having initial velocity, that is u, that is equal to 2 meter per second it is having, and finally it is coming out from a certain point. So when it is coming out at that point, is the velocity will be remain same or not? According to kinematics, you know that. Okay, kinematics in this case, what you understand in the kinematics topic, horizontal velocity will not be affected by any component, but vertical velocity will be changes. So here electric field is acting vertically, so the charge velocity will changes due to vertical field, that is electric field, but horizontal field will not be affected. So in this case also the velocity will be changes. That means in this there are two types of velocities are there. Initially it is having only horizontal velocity, but when reaches to the end of the plates, it is having two velocities. One is horizontal velocity, that is Vx, and vertical velocity, that is V. So horizontal velocity will be remain same because there is no field is acting along x-axis, so that is nothing but 2 meter per second I can take it, but vertical velocity we don't know that in the question. So second concept, you need to find the what is the velocity when reaches to this position. When charge reaches to electron reaches to that point, what is the velocity of that? Second. Now third, now when it is coming out of that point, at that point end of that, how much angle it is making? So if you observe this direction of the electron, it is making some angle theta with respect to x-axis. Yes or no? So that means this is the x-axis if you say, this is the y-axis if you say, the electron is ejecting out, coming out from this one by making an angle theta. So they're asking theta value. That means in this case, there are two velocities are there for this electron. One is called horizontal velocity Vx, second one is called vertical velocity Vy. So using the concept of triangle, using this triangle, that means if we construct a perpendicular, we are getting a triangle. Using the triangle, using the formula of tan theta is equal to, that is y-axis by x-axis. What is the y component? Vy. What is the x component? Vx. So these are the three concepts you must understand to solve the problem. First, electric field. Due to electric field, the path of that one is anyway parabolic. They are given in the question already very clearly, and when it is enters, it travels a distance of length of the plate inside the complete. Up to that it experiences a force, and due to that what happens? Velocity of that one changes. Which velocity? Vertically, because electric field is acting vertically, but horizontal velocity will be remains same. At that moment when it is coming out, it is making an angle theta. The theta can be calculated using the concept of velocities of that electron while it is coming out as a vertical velocity and a horizontal velocity, as using geometry tan theta is equal to Vy by Vx. Using that we can calculate. Now our requirement of calculation is, what is that? Vy. Because Vx value already you know that is 2 meter per second. Vy value you need to find. How to find the Vy value? So first concept anyway you got it. Second concept, there is a distance is given. So to find the Vy, so initial velocity is given and the final velocity you have to know that. So distance. So initial velocity means what direction it is? Vertical. So you take the initial vertical velocity of this electron is 0 because it is going horizontally. There is no velocity of this one. So uy value is equal to 0 initially. So that is uy 0. It is traveling through a distance of, how much distance it is traveling? It is traveling through a distance of, we don't know that what distance it is traveling. So that distance you can take it as sy. So it is required or not, we'll check it that. But it is traveling a distance of what? X distance it is traveling. So that you know that. And that distance is equal to length of that is equal to 1 meter. Next, we required vy value. And here acceleration to know before applying the kinematic equations. So in this case, sy is not given, uy, vy, ay, you know that, and you take the concept of v is equal to u plus at. If you take in this concept, vy is equal to uy plus ayt, I can take this formula. So what is vy? We need to find what is uy, initial vertical velocity, that is 0, plus what is a, acceleration. I can write in terms of force by mass into time. So time is not given. So how much time it will take from here to here? The time taken for the electron to reach from this position to this position is equal to same time. In the same time, it will go in a forward direction. So that means the distance, okay, the time is equal to, I can write in terms of distance by velocity. I can write time is equal to distance by velocity. That distance by velocity I can write. You know the velocity along horizontal direction. You know the distance along horizontal direction, that is time taken for the particle to cover the horizontal distance, same time it will take to move upward direction. See, the concept is how much time it is taking to cover this length. Okay, same time it will take to move. So that time I taken using the known concept of horizontal distance by horizontal velocity. Apply here. Vy is equal to, what is force? Force equal to Eq by m into, that is Sx by Vx. This is a concept, formula based we can able to. So Vy is equal to, what is the electric field? What is the electric field values? Now you can substitute here. They given electric field value very clearly, 8 into m by E. That means 8 into m by E. And into, what is Q? Charge. Here electron is a charge, E by m. So E get cancelled, mm get cancelled. Now what is Sx? Distance travel along x-axis. What is the distance? That is length. Length is equal to how much? 1 meter. By, what is the velocity along x-axis? Initially 2, final also 2, because horizontal velocity will not affected by any other component, it will be remain same. So that means you can write as 2. So now if you solve it, this is how many times? 4 times. So velocity along y-axis is equal to how much? 4 meter per second at that instant. So now what I can do it? Now you can use the, okay, last concept to find the theta. So what is the last formula? Tan theta. Tan theta is equal to nothing but vertical velocity by horizontal velocity. Now what is vertical velocity? Got 4. What is horizontal velocity? We have 2. That is nothing but how much? 2. So from this, theta is equal to, this is tan theta is equal to, now theta is equal to how much? That is tan inverse of 2 is the answer for your question. Now look at the options here. What angle the okay, electron comes out, okay, from the plates is equal to, second option, tan inverse 2 is the correct answer for this question. Now this is the question, theoretical derivation question. Already maybe you can check the previous videos. I given the derivation of this one. Just in a short way we'll discuss, and just I'll give the formula for this. What the question is, uniform charge disk. This is one of the disk having radius r. We are given charges to this. So what they're asking to, okay, find the electric field intensity due to this charge, due to this charged disk. What where they're asking, find the electric field intensity along the z-axis at a distance of z. This is the taken as z-axis, and they're asking to find the electric field intensity at any point which is at a distance of, okay, z. Z is the distance of this one, r is the radius of this. So the derivation for this one already we given in the previous classes. You check that the derivation of this one is electric field intensity is equal to sigma by 2 epsilon naught into 1 minus z by under root of, that is, okay, r square plus z square is the formula for this. So which is the correct formula? You check it in the given option. So if you see the first option, sigma by 2 epsilon naught into 1 minus z by z square plus r square whole power 1 by 2. This is the correct option for this one. You can check the derivation in the previous classes videos. This is also one of the conceptual question asked in the previous IITG 2003 question paper. What the question they're asking is, a metallic shell has point charge Q, and this is the metallic shells they given for the options you can see, and otherwise we can redraw this one. This is the way we can take the metallic spheres. So in this case, it is having cavity, means inside there is no charges at all. There is a cavity inside. So which one of the following is correctly represents the electric lines of forces they're asking to find? So which diagram gives exactly the electric line of forces diagram? So there are two. This is one of the shell is given. In this case, this is the center. It is which is having cavity. This is the center cavity. So in this case, when if the charge Q is kept inside the cavity, if you are keeping the charge inside here, now what is the electric field diagram? How the electric field diagram will be takes place? So whenever you taken the charge here, what happens is first, this is a positive charge. If you say there is induced charges will be developed inside the metallic conductors. Induced charges will be developed. Now due to this one, what happened? There is exist a electric field of lines inside. These electric field lines will be looks like this. So from the charge, this is the way the electric lines will be appears in all the directions. And you can see the diagram also in the options also you can see this is the way these electric lines will be originated. So these electric lines, if you observe that one, these electric lines are equal, all are equal in direction, opposite in equal in magnitude, opposite in direction. That's why what happened, net electric field will be 0. So inside the electric field will be 0. So the electric lines will be equal and opposite uniform. One. Next, this is the what type of metal? Metallic shell. Metallic shell means you know that concept. In the metallic shell, electric field is always 0. When the electric field is 0, still there is no electric lines exist inside the metallic shell. Here net electric field is 0. Electric field is not 0. Net electric field is 0. So, but in the metallic shell there is no electric lines. So that means we are not finding any electric lines in the diagram. Which is, if you see the first option, there is electric lines are present. So first option not correct. Second one, there is electric lines are present passing through the metal. So it is not correct. And third one, there is no electric lines present. It may be correct. And fourth one, there is electric lines passing through the metal. So third option is correct. And also not only that one. Now this is the negative charge, means automatically here the positive charges will be accumulated, induced charges will be developed outside. The positive charges will be induces here. Due to this one, the electric field direction, if you see, the direction of the electric field will be normal to the surface. It is always. So this is the way the electric field will exist in this case. So if you see this one, every electric line which is coming out will be normal to the surface only. So that is also one of the important concepts you have to understand, because the remaining lines are somewhere may not be normal according to the some previous other diagrams also we can explain. So this is also one of the important concepts you need to keep it in mind. Now this problem related to one of the equilibrium condition based concept or null point based concept. If you see this the question, what is given? Two particles A and B. This A particle, B particle, having charges 20 microcoulombs and minus 5 microcoulombs respectively, held fixed between the separation of 5 centimeters. Both are separated by distance how much? 5 centimeters. At what position a third charge placed should have to be placed so that it does not experience a net electric force? That means you have to keep the charge at a place where the no electric field exists. That means if there is no electric field, means no force acting on the charge. So because electric field are defined, force acting per unit charge is called as electric field. So we have to find the position of the charge where you have to keep so that it does not experience any force, means null point we need to find. So concept based, first there are two concepts here. What position you will get the null point? If you taken the two positive charges, null point always null point. Where you are going to get the null point? Null point always will get between the two charges. Between the two charges, along the line joining always. Along line joining. This is already we discussed in the previous. If the two charges are one is plus, one is minus, unlike charges. In this case, null point will be always outside. Null point will be outside. You will get outside of the two charges along line joining of the two charges. It is common. But what is another point where this null point you are going to get? This null point always will get near to, okay, that is small charge. That is also one of the important point you must keep it in mind. So here when you take in the two positive charges, null point will come inside in between the two charges. If you take in the one is plus, one is minus, you will get the null point outside. But where that null point you are going to get always near to the smaller charge. If you observe 20 microcoulomb, 5 microcoulomb, which is the smaller one? 5 is smaller one. So this is the region where you are going to get null point. Now the distance of this one they are finding, they are asking to find. If x is the distance of that null point, okay, sorry, the distance of the null point, if you say as x, so from where it is we will discuss later. Okay, the null point, okay, null point is nothing but x. So here the null point distance, if you are calculating as a first charge, always the formula for the null point is we are taking as x equal to, that is r by 1 plus or minus under root of q2 by q1 is the formula for this. Here is. So in this case, unlike charges means you have to use the minus, like charges means plus, already we told, that is we have to keep it in mind. So our concept is the x is the distance of the null point always from the first charge. So if you choose in this one as the first charge and this is the second charge, with respect to that I am doing the calculation here. So x equal to r is what? Distance between the two charges, that is 5 centimeters, 5 into 10 power minus 2 I can write, by 1 minus under root of q2, second charge. What is second charge according to our discussion? That is 5 into 10 power minus 6 by, what is first charge? First is 20 microcoulomb, that is 20 into 10 power minus 6. So if you cancel this one, 10 power minus 6 cancel, this is 5 fours, that is nothing but how much you are going to get? 5 into 10 power minus 2 by 1 minus 1 by 2 you get, because 1 by 4 is nothing but 1 by 2, root 4 equal to 2. So if you solve this one, how much you are going to get? 10 into 10 power minus 2, that is nothing but x value is equal to 10 centimeters. X value 10 centimeters means from which charge? First charge. What is the first one? This is the 20 microcoulomb is the first one. So from the first one, this null point is formed at a distance of x is 10 centimeters. If you look at the options, what is given? At 5 centimeter from 5 minus 5 microcoulomb. If you look at this one, the distance between the 20 and minus 5 is 5 already. From here to here is 5. What is the remaining? Total is 10, no? Remaining is 5. So the 5 microcoulomb charge, that is minus 5 microcoulomb charge, is at a distance of how much? 5 centimeter from the null point. So at 5 centimeter from the minus 5 microcoulomb on the right side. This is what side it is? Right side. This is called left side. So the first option is correct here. No need to go for remaining, because at 1.25 centimeter we did not got the distance of the null point anywhere 1.25, we got 10 centimeters, so second option is not correct. Third option 5 centimeters. So look at here, at 5 centimeter from 20 microcoulomb, but we got 10 centimeter from 20 microcoulomb, so C also not correct. And third one, okay, at between, okay, midpoint between the two charges. Concept is what? One is plus, one is minus means always you'll get outside, not between. So option A is correct. Now this is the one of the question related to electric field due to system of charges. 4 charges are given. How many? 4. They given. You can just see the diagram. They are arranged in the 4 corners of the square. One is q, second one is minus 2q, third one plus 2q, fourth one minus q. Each charge how much magnitude? That is q is equal to 1 microcoulomb. Each one having 1 microcoulomb. Then field at the center of the square will be how much? What is the electric field intensity at the center? They are asking to find. What is the side of length? 5 centimeters. The length of this side is equal to A I am taking, that is 5 centimeters is the length of this. A is the side of this. Now to find the electric field intensity at the center, what the concept we have to do? To find the direction of the electric field at any point, we have to imagine the test charge there, and these charges will either attract or repulse the test charge. What direction they are repulsing or attracting the test charge, that is the direction of the electric field. So first I am taking this charge, okay, first corner, this is Q, capital Q. Now this one, okay, repel this test charge in this direction. This is the direction of the repulsion, we can say. First I am indicating only diagram. So this is the direction of the repulsion it is. Okay. So next one, if you observe the next one, minus 2q. Minus 2q, what direction it repels? That is minus. Minus and test charge is plus. So it attracts. What direction it attracts? This is the direction of attraction takes place. This is the direction of attraction. In third charge, plus 2q. Plus 2q plus plus repels. So from here, the direction of the repulsion will be in this direction. So along the same line, there is a repulsion here. Next one, minus 2q. Minus will be attracts the, okay, this charge in this direction. So this is the direction of the attraction, we can see. So I can indicate the direction of the force of attractions here. So all charges are, magnitudes are not same. That's why. So if you observe here, this is plus q, this is plus 2q. Both fields are opposite, but magnitude says one is double the other. Which is double? Below one is double. So both are opposite means net will be difference here to take. If you take in the difference of that one, the difference in the magnitude of that one you are going to get for, okay, what we'll get? You will get in the form of okay, so upward direction you will get. So resultant direction of this one I can write as like this. This is the direction of that result. Due to which charge? Due to the plus 2q charge, we have a direction of the field upward direction. Now minus q, minus 2q, both are attracting opposite direction. So one attracting double times of the other. So minus 2q is attracting more. So the resultant of this one will be in this direction. So if you observe these two result, okay, force of attractions, both are acting supported by a certain angle here. If you observe this one, both are supported by certain angle. This angle is equal to how much? 90. So when the two electric fields are acting in particular separation, then the resultant of these two will be acts in this direction. This is the resultant of this. Now we need to find the resultant of this one. That resultant is, that is nothing but PR is equal to how much they're asking to find. So first I am taking the net electric field intensity. Due to negative charges is E minus, due to positive charges E plus. Okay, anyway the E plus value is equal to due to one charge, because E plus is one is capital Q, second one is plus 2q. So dominating is difference is 1q charge. So electric field also due to one charge. So I can write as K into Q by distance, square of the distance of that. What is the distance? Center. They are asking to find the electric field intensity at the center from the charge. What is the distance? This is the distance we need to find. So the side of the length of the square is A. So this side is also A if you taken. So what is the, this is the distance A if you say. Now this is also distance of the side is A. Then we need to find the distance of this one. That means this is also distance A. I am taking here all the sides A. So if you take an A like this, so I need the distance of this one. For that, you take the distance of this. What is the diagonal of this one? The diagonal length is equal to how much you get? Root 2a, and this is a half of that. Now this half length you are going to get as a by root 2 you will get, because root 2 by a, root 2a by 2 is equal to a by root 2 you will get. That is nothing but this is a by root 2 you will get the length of this. So k cube by square of the distance, that is nothing but a by root 2 whole square you will get. E plus value. Similarly, what is E minus value? That is E minus due to negative charge. That is also one is minus Q, one is okay minus 2Q. So both are opposite. One minus Q will be effective. So in this case, the K into Q by, so distance is same from center to, okay, from center to here. This is the distance we need. The distance of this one is equal to here also how much? A by root 2 only. So I can write that is A by root 2 whole square. This also. So if you solve these two, what you are going to get? Net electric field at that point, that is resultant electric field at that point is equal to, that is nothing but, okay, both are supported by an angle of how much? 90 degrees. So you have to use parallelogram law of vector addition, that is E plus square, E minus square plus 2 into E plus E minus into cos 90 degrees. Cos 90 anyway 0, this total term will become anyway 0. So this is under root of. So if you observe the both of magnitudes, plus and okay, this E plus and E minus, both magnitudes are same. Same means I can take it as E plus value, E minus value are equal. So electric field plus is equal to electric field minus both are same, that is equal to E you can take. So if you take on that one, you are going to get this is 2 E square here. 2 E square means how much you will get? Root 2 E. So now ER is equal to resultant electric field intensity is equal to root 2 times of electric field. What is the electric field formula? K into Q. What is K value? 1 by 4 pi. So not into Q by, okay, distance, that is nothing but A square by 2, where the 2 can be make it to numerator. Now if you observe this one, what I can write this, you have to calculate the value because the values are given in terms of numerical values. So this I can write as 2 root 2 into 1 by 4 pi epsilon naught, I can write as 9 into 10 power 9 into charge. How much charge is given? Charge value, each one is 1 microcoulomb is given in the question. 1 into 10 power minus 6. Look at here, this is 1 microcoulomb is given. And A value, what is the A value given? A value is 5 centimeters is given. So 5 square means 25 into 10 power. Okay, so I write to make it clear. This is 5 centimeters means 5 into 10 power minus 2 whole square. So now we need to solve this one. So what is the value you are going to get? This is ER is equal to. So first to calculate this is 18 root 2 into 10 cube. In the numerator you get by. This is 25 into 10 power minus 4. So here this is plus 3 minus 4 means if it goes up it becomes plus. So 18 by 25, that means 18 into root 2 value 1.4 I can write. So root 2 value is 1.4 by 25 into 10 power minus 7, sorry, plus 7. 10 power 7 you get. Now 18 into 1.5, okay, 1.4 by 25. Now you have to calculate this value. Nearly how much you will get, we'll check it. Now if you calculate this value, this 18 into 1.4, nearly you are getting 25.45 nearly by 25 into 10 power 7. So this value is approximately, we are getting, that is 1.02 into 10 power 7 you are going to get. So resultant electric field intensity at the center is equal to how much? That is 1.02 into 10 power 7. So unit says that is Newton per coulomb is 1 unit, R volt per meter is another unit. So if you see this one, the first option is correct, that is 1.07 into 10 power 7. And here there are two options are given, upward and downward is also given. So if you look at the diagram, what direction we got? Upward. So first option is correct according to the diagram. Now this question also, one time they asked in the previous IITG exams, most important concept here. Two equal positive point charges separated by distance of 2a. The distance of the points from the center of the line and the two charges are equatorial line along the, okay, two charges on the equatorial line. Means first you take the line joining of this one. This is the way I am taking the line joining. And here I am taking two charges here. Similar, two equal charges they said, one is Q, second one also Q. And both are separated by distance of how much? That is 2. Now this is the line of bisector I am saying here. Line of bisector means which divides the total line into two equal parts. Now along this line, okay, they are asking to calculate a test charge is placed. That means if we are keeping any test charge along this line, that is Q0 is along this line, Q0 if you placed, at which, okay, where the force experienced by the test charge will be becomes maximum. And that means what distance you have to keep so that the force acting on the test charge will be maximum. So that distance is nothing but x. They are asking to find the x value here. The relation is given a by root x. They are asking that x value in terms of a. So what is here? What is a here? A is nothing but distance of the charge from the center of line of bisector. This is also distance of the charge from the line of bisector. So to calculate here, first what you have to understand is what direction the force is going to act. What direction the force? If you observe the force concept, okay, so this charge repels this one in this direction, right? Similarly, this positive charge repels this one in this direction. that you know that. And both are making certain angle theta here because same distance, same angle. So now, according to geometry, I can take it as adjacent angles are same. Now, this is the force F if you say, this is also force F if you say. Resolve this F into components so that along this line you'll get one force, that is nothing but due to component of this one, and also you'll get one more force. Okay, along the same line you'll get one more force along this line, component of below. That means what are the components here? The components is, okay, that you are going to get F cos theta and F cos theta due to this, and remaining is, this is the one of the component vertical efforts, and that is one, another one vertically downwards. So this component is nothing but F sine theta, and this is nothing but F sine theta. Now these two F sine thetas are opposite in direction, so there is no effect of force at this point, so it is 0. So only we have F cos theta, F cos theta. If you take on the net force at that point, net force equal to, that is nothing but 2F cos theta is the formula for this. So in this case, 2 into, what is F? Force between the two charges. This is one charge, this is another charge. The force between these two, okay, you can calculate in terms of K into Q naught by R square. What is the R here? Distance between the charge to the point. So what distance that is? You take it as R is the distance. If you write if you written this one, R square into, what is cos theta? From this triangle, if you observe this triangle, from the line of bisector, we have a triangle. From this triangle, I can write cos theta is equal to x by r. So this formula will becomes 2k capital Q small q naught x by r cube you get. So in this case, they are asking to calculate maximum force. Condition for force. Force value changes with respect to distance. So we will take the relation with respect to distance. So to take the, okay, F value with respect to distance, what you have to do is dF by dx value has to become equal to 0. That means you have to differentiate the above equation. So d by dx of F is equal to, I can write as d by dx of this total value, that is 2k q small q naught x by r. What is r value from this triangle? I can write this r value is equal to under root of, because x is one side, a is one side, I can write as x square plus a square. So if written that one, cube, we have a cube is there, so it becomes x square plus a square whole power 3 by 2 square. Yes or no? Okay. Because r square is a formula, x square plus a square we are going to get, and whole cube, that is we have a formula of cube is there. So cube means x square plus a square whole power 1 by 2 whole cube, nothing but 3 by 2. So in this case, this is 0, df by dx. 2 is constant, no need to take. K is constant, capital Q, small q, these are all constant. Only differentiable functions are d by dx of x by x square plus a square whole power 3 by 2. If you differentiate this one, what you are going to, it is in the form of u by v form, u by v form. Okay, whenever we are doing with in terms of u by v form, then we have to use the formula d by dx of u by v is equal to nothing but, I can write as, okay, dv by dx into u minus v into du by dx by v square. I can use this formula. If you apply that formula, what you are going to get first? You are going to get dv by dx. So that means in the place of, okay, d by dx of x square plus a square whole power 3 by 2 into x minus, next d by dx of, that is v. Okay, v take it outside, v into d by dx of, I can, sorry, not v. So v is nothing but in the place of what we have here. So x square plus a square, in the place of v what we have, that is x square plus a square whole power 3 by 2 into d by dx of x, like this you have to take, by total divided by, that is x square plus a square whole power 3 by 2 whole square, because according to formula it is a square is there. In the formula we have square, so we can write the square of that. Now if you solve this one, what relations we are going to get? So anyway, it is 0, no need to calculate, just you take cross multiply, it becomes 0. That's all, right? Next, in this, it is in the form of d by dx of x power n form. Formula is n power n, that is 0 is equal to 3 by 2 into, that is x square plus a square whole power 3 by 2 minus 1, n minus 1, 3 by 2 minus 1, that is nothing but 1 by 2 you will get. 3 by 2 minus 1 is 1 by 2, and that is, again if you differentiate x square value you are going to get 2x, and already we have, that is 2x square minus, and this value anyway dx by dx equal to how much? 1, so we are going to get x square plus a square whole power 3 by 2 by, this is anyway we are not having any by term because we already calculated this, so take this minus term that side. If you take a minus term this side, what you are going to get, that is x square plus a square whole power 3 by 2 is equal to, so this is 3 by 2. This 2 get cancelled, so I can write this one as only 3 into x square plus a square whole power 1 by 2 into x square, if it is. So if you solve this one, this is 1 by 2, here 1 by 2 get cancelled, so cube is there. So x square plus a square whole cube, x square plus a square, okay, so cube also, here we can cancel 1, here we are going to get only one term is there, so that is x square plus a square. It will make the square that side becomes root, that is root means you are going to get root 3 x here. Okay, this is the way the term you are going to get x square. So x square plus a square. So if you solve this one further, what you are going to get? You check it. Here we have a mathematical, okay, error is there, just you check it. We can't cancel the, okay, here this step, just I'm doing again. So if you observe this step here, what the variation, the remaining everything is same. So x square plus a square whole power 3 by 2 is equal to, this is nothing but what we have, that is 3 times of x square plus a square, that is whole power 1 by 2 into x square. What you do is squaring on both sides. If you do, the 1 by root 2 will get cancelled. Squaring on both sides, I can write x square plus a square whole cube between cube. If you squaring on this one 9, x square means x power 4, and this will becomes only x square plus a square. Square and root get cancelled. Now here 1 x square plus a square you can cancel, you will get 2. So that 2, if you make it that one, that side it becomes root value. So root value is equal to what I can write, x square plus a square is equal to, that is nothing but 3x square. X square plus a square equal to 3x square means what value you will get, a square is equal to nothing but, that is 3x square minus x square, that is equal to, you are going to get 2x square, that is a square is equal to. So x square is equal to nothing but a square by 2. So x equal to nothing but a by root 2. So if you compare with the given question, x value is equal to how much? A by root 2 distance, it becomes maximum. So in the place of that, what is given? A by root x is equal to a by root 2. So that means what is the x value? X value is equal to nothing but 2 is the answer to the question. So this way you have to solve the question. You have to take care while doing the procedure of differentiation. Now this question based on electrostatic force, 3 charges are given, 5 microcoulomb, 0.1, 6 microcoulomb, and third one 0.3 microcoulomb are located at 3 vertices of right angle triangle, whose sides are AB, BC, CA values are given. So you take one of the right angle triangle, so that using the right angle triangle I can able to explain the structure of this. This is one of the right angle triangle we can take. Now this, in the right angle triangle, what are the charges given? 3 charges given. So 5, 0.16, 0.3, and they given very clearly uh, point A is at right angle corner. This is the right angle corner which makes an angle 90. At this point we have a point A and experiences how many Newton. That means at this point A, at this point B, at this point C, I can say. Now, what is the force acting on this charge when it is placed at this point? A point charge. How much force it is going to experience? A point charge. What is the A point charge? That is 5 microcoulomb is the charge at A point. Now, B point. What is the charge? That is 0.16 microcoulomb is the charge here. C point, that is 0.3 microcoulomb is the charge here. Okay, so we need to find the force experienced at A point in terms of Newton. So we take the direction of the force because it is a system of charges, 3 charges which are okay influencing each other with a force of repulsion because 3 are positive charges. So first on A, if you observe this one, C charge repels the A charge. What direction? From here it is going to repulse in this direction. This is the direction of the repulsion on A by the C charge. Okay, next B charge 0.16 also repels the A charge because that is also positive. All are positive only. You check, okay, check it carefully before. So this is also positive charge. So if you observe this one, these charges will repulse. This is the direction. Both repulsion values, both charges are different values. So this repulsion value is also different. So I can write this one as okay, B point repulsion I am taking as FB, and the C point repulsion I am taking as FC. So both are separated by an angle of how much? 90. So the resultant of these two will come in the in between these two charges, in between these two, not exactly between these two, because these forces are not same. Always the angle made by this resultant will be near to the heavier charge. Suppose if FC is more, FB is more, heavier force, sorry. If FC is more or FB is more. If FC is more, this angle will be this. So that means the resultant angle will be near to the FC. And FB is more, this resultant will be near to the FB. So here they're asking what question? Only force they're asking. So this is the force, that is we are calling as resultant force they're asking. So directly you can do it. They're not asking any angle concept here. Resultant force equal to under root of two forces, that is force due to B, FB square plus FC square plus the angle between these two is 90, that is 2 FB and FC cos 90 degrees. So cos 90 anyway is 0, so we can write like this. Now what is FB value? Calculate here. FB force between force on A due to B. So formula is, that is 1 by 4 pi epsilon naught Q1 Q2. Q1 charge first, Q1 charge is B point charge, that is 0.16 into 10 power minus 6 into second charge is A charge, that is 5 into 10 power minus 6 coulomb by square of the distance. What is the distance between A to B? If you look at the diagram, they are given very clearly. AB is supported by distance of 3 centimeters. 3 centimeters means 3 into 10 power minus 2 whole square meters. Now we need to calculate this value. So we'll do it later. First we'll write the value of FA also. What is the force due to C? Sorry, not A. What is the force due to C? FC is equal to nothing but same formula, 1 by 4 pi epsilon naught. The charge first, C charge. What is the C charge? 0.3. C charge is last one, 0.3 microcoulomb, that is 0.3 into 10 power minus 6 into A charge. What is A charge? 5 into 10 power minus 6 by square of the distance. What is the distance between C point and A point? The distance of CA is given as how much? 3 centimeters. C to A is given as 3. So that is also 3 into 10 power minus 2 whole square. I can take. Now calculate these two values and substitute in the above equation. First, this value to calculate how much we can write, that is directly I am writing 1 by 4 pi epsilon naught is nothing but 9 into 10 power 9. I can write remaining is, this is 16 5s are 80 into 10 power minus 8, because 2 after decimal 2, that is 10 power minus 8 minus 6, that is 10 power minus 14 minus 8 minus 6. Next denominator 9 into 10 power minus 4. So what I can cancel here? I can cancel 9 get cancelled. and 10 power minus 4 here, minus 10 and 9, minus 1 left, minus 1, this 0 cancel. How much you are going to get? You got 8 newtons. Similarly, if you come across case of this one, which one? The case of this FC, that is 9 into 10 power 9 into, this is 3, 5 is 15, I can write 15 into, okay, 1 decimal, and this is 10 power minus 7 minus 6, that is minus 13 by 9 into 10 power minus 4. So here also same way, 9 get cancelled, 10 power minus 4, how much it is? Minus 9 you get, minus 9 plus 9 cancel, you got 15 only, that is 15. So one is 8, one is 15. So what is the resultant force? That is resultant force equal to under of 8 square plus 15 square. So how much you are going to get? Under of 64 plus 225. So if you solve this one, okay, how much you are going to get this value? This is under of 289 you are going to get. Okay, 289. 289 means what is the root value for the 289? So how much you are going to get? This is, you are going to get nearly 17. So answer for the question is, this Philip has to be 17 is the answer for the question. So resultant force on A is equal to 17. Now this question is given in the previous competitive examination. Most important concept here, because sometimes the student will get stuck into the problem how to do this type of questions. So here comparison of these some other concepts, you can able to solve the problems easily. So here in the first year you are learning the projectile motion. If you understand the projectile motion clearly, you can solve this problem easily by comparing with that, because no need to all the time apply the conditions. So here what is given? A uniform electric field is given. This is the electric field is given, that is minus 400 root 3y is applied in the region. As you're looking like this, what direction it is acting? Downward direction. And what we done, we projecting a charge here. There is a charge we taken here q. That q charge we are projecting with a velocity u, and the speed of that one is given 2 into 2 root 10 into 10 power 6 meter per second is given. This particle is aimed to hit the target t. This is the target t, it has to hit. So it has to, it means what direction the, okay, the charge has to move, in this path, that is called parabolic path. So parabolic path concept where you learned in the first year, kinematics you learned, that is two-dimensional motion, projectile motion you learned. That you have to recollect it, because how you are applying, that is important for here. This particle aimed, which is at a 5 meters away. The point is what distance it is? It is at a distance of 5 meters. Now entry point into the field. Now take the q by m value they given, and they given some options here. If you see the options, what is given? The particle will hit t. T means target. Okay. If you are projecting at an angle of 45, that means if you project the particle with angle 45, it is going to hit the point of t. Yes. Second option also in the similar manner, if the two angles given 30 and 60, both cases it will hit the target they are saying. And third option given, time taken by the particle to hit. Time is given. What time it is going to hit the target, that is a given. Fourth also, time taken is given. So here concept is, you take the projectile motion. If you observe the concept of projectile motion, I'm taking the coordinate system here. This is the coordinate system. Okay, so in the coordinate system, whenever you project the projectile, so this is the way you are going to project the projectile. In this case, this is the way you are going to project any body with velocity v making an angle theta. In this case, this is follows the parabolic path due to one of the concepts, you know, that gravity. Yes or no? So here gravity, what is gravity? It is one type of acceleration, okay, by the earth. So acceleration due to gravity we are calling. It is acting downwards. Now due to this one, it is moving in the parabolic path. The same concept if you compare here. So in this case also, the given question, whatever the question which is given, in this case also, the parameter of this charge which is moving will be same, like we can take it. So that means in this case, what is acting vertically downwards? In this case, in the place of gravity, there is a electric field is acting here in the place of gravity. In the place of body, here we are projecting a charge, that is q. that is also given the charge q, which value, the charge of q, just this is the q which we are projecting. So after projection, this is reaches to one of the target, they set t. Now it follows the parabolic path due to this electric field when we are projecting the body with the velocity u, which makes an angle theta. So in the place of gravity, you imagine that electric field. Now gravity, what is the gravity is doing here? Gravity is applying the force on the mass body. Yes or no? That is acceleration due to gravity, that means force due to gravity. Here also electric field also applies the force on the charge particle. The charge particle, when you take in, it applies the force, that is force due to electric field. So that means here acceleration due to electric field. What is acceleration due to electric field? That is force by mass. Concept you take. Force equal to that nothing but E cube by m concept you take to solve the problem here. So to solve it here, first option you check it. The particle will hit the T. T means target. So here what is the target? From here to here is the target. This is called as per the projectile term, called as a range. So range value is equal to, what is the range? Range is equal to, already value is given, 5 meters. Range is equal to formula u square sine 2 theta by g is the according to gravity. If the gravity is producing acceleration, this is. But in the case of here, there is no gravity, only electric field is there. Due to that, the formula can be modified into u square sine 2 theta by this a value. I can take it in terms of electric field acceleration, that is, you can write E cube by m. But in the question, you check it properly. If they are mentioned any gravity, then you have to take the resultant. So they are not mentioned anything. That's why directly I am going with respect to acceleration due to only electric field, only base we are solved. So range value how much given? 5, because in the diagram 5 is the range, is equal to, what is u value? In the question they given 2 root 10, that is 2 root 10 into, that is 10 power 6 whole square into sine 2 theta. So what is the first option given? 45 degrees. Substitute here. If you substitute the 45 and check the value of this, both are becomes equal or not. What is E value? Electric field. How much electric field we are applying? That is 400. That is root 3. Okay. That is minus indicates a direction only. No need to worry about it. And that what is Q by M? This Q by M value, they given very clear in the question. Take it as 10 power 10. This is take it as 10 power 10. Now check it that both the values are getting equal or not. If the right side is equal to left side, then we can say the particle is going to hit at the target exactly there. So if you observe this one, this is 4 into, right, root 10 whole square, nothing but that is 10 you will get into 10 power 12 into sine 90 is equal to 1 by, this is 400 root 3 into 10 power 10 you are going to get. So in this case, so here I can cancel here 4 10 times. So this you are going to get 1 by root 3 into, this is 10 power 11. That means we are going to get 10 power 1 here. That is 10 by root 3 here. So first option is 10 by root 3 is not equal to 5. So first option not correct. Go to the second option, 30 degrees. Substitute in the place of theta 30. If you put the value theta 30, how much you are going to get? That is range is equal to how much you are going to get? That is nothing but 4 into 10 square. Sorry, 10 power 12 into sine 2 into 30. 2 into 30 means 60. Sine 60 value how much? That is nothing but root 3 by 2 into, in the denominator, what is the E value? That is 400 root 3 into 10 power 10. So if you solve this one here, what I can write here, this is 2 times we can cancel. This is 2. Okay, 0 0 cancel. This is 2 20s we can go, and root 3 get cancelled. That is nothing but 1 by 20 into 10 power 2 unit. That is nothing but 100 by 20. 100 by 20 means 5. So you got the value. So that means second option 30 is correct. Now what about 60? 30 and 60 is called as complementary angles. That you have to know the concept. 30 and 60, because if theta is the angle, 90 minus theta is called as complementary angle. 30 is the one angle. If it is another angle also becomes 60. Both will gives the same range. So second option is correct. So if you want to check the third option, you can go for third option. What is the third option? Second option anyway correct. Third option is time. So what is time here? Time nothing but Okay, when the charge is projected from here, it reaches to this point. The time taken to reach to that point is called as time of flight of the charge. The time of flight of the charge formula to use sine theta by g is the formula for projectile, but in the case of g, what we are using e q by m. This is the formula for this. Now substitute the values here. 2 into, so what is u? 2 into 2 into root 10 into, that is 10 power 6, 10 power 6 into sine 45. Sorry, theta is not given, right? So time taken by the particle to hit could be root 5 by 6. You take okay, 45 anyway not correct. You take the 30. Okay, sine 30 value is 1 by 2. I am taking here 1 by 2 into, so e value is equal to how much? E value is 400 root 3, 400 into root 3 into q by m value 10 power 10. Now this is 2 to get cancelled. Now this is what we can cancel. We can't cancel it, is we are going to get 1 by root 3. So we'll check it. This is 200 and this is okay 10, that is nothing but 4 will be there, that is becomes minus 10 power minus 1. So this is root 10 by this value root 10 and root 3. Root 10 by root 3 value is, you are going to get, okay, if you taken the 2 inside, that becomes 4, that is root 10 by 12. Root 10 by 12. Root 10 by 12 means 2 table 5 and 5 6, 5 by 6 you will get, and this is 10 square, 10 power minus 6 here. Okay, so that means you are going to get how much? Root 5 by 6 microseconds. You are getting the answer for this. Clear? If you substitute these values, the time, that means the C option also correct. So it is a multiple answer question, 2 options, okay, 2 more than 1 option choice questions. This is one of the last model question we'll do, and later we'll go for the next concepts in the electrostatics, electric dipole. Okay, so what is the last question we are going to discuss today? Electric field at a point is given, coordinates are given 30, 30, 0, 3 dimension due to charge 0.008 microcoulombs placed at the origin B. Coordinates are given in terms of centimeters. They given options. If you see that I plus j, I plus j, I plus j, like that means in terms of component method they given. So for that, first you take the coordinate system and how the charges are arranged, you try to understand. This is x-axis and this is y-axis, and in this case we have a charge at 30 comma 30. Suppose if I'm taking this one as a 30 and okay, and here also I can take it this one as 30 if taken. So this is the common point of that 30. So that means this is the position of the charge, position of the point. They're asking where the electric field is. They're asking to find the direction of the electric field. Z-axis anyway 0, no need to take here. This is x-axis, this is y-axis. Now where the charge is present, 0.008 microcoulomb at origin. This is called origin. At this point we have a charge is equal to 0.008 microcoulomb we placed. Now if you imagine that what is the direction of the electric field at this point, you take the direction of the electric field at this point in this direction. So this electric field they are asking to find in terms of I and j component. First what I will do is, this is 30, this is 30 means along x-axis 30, y-axis 30 means this, the resultant of these two will be follows exactly diagonal. This is the first point, 45 degrees it makes. Now next what you do is find the length of this from here to here, length how much, because this length is 30 and this length is 30, so this is 30, this is also 30. Using Pythagoras theorem I can find this value is equal to how much you are going to get, 30 square plus 30 square, that is under root of 1800, 900 plus 900, that is under root of 800. So to find the okay electric field intensity at this point P, electric field at point P is equal to, formula is 1 by 4 pi epsilon naught charge q by square of the distance of that. So what is 1 by 4 pi epsilon naught? 9 into 10 power 9 into what is charge q, that is 0.008 microcoulomb, that is I can write as 8 into 10 power minus 9 coulombs I can write. Micro is 10 power minus 6 and 3 decimal points 10 power minus 9. Okay, that is q by r square. What is our distance? How much distance? Under root of 1800 whole square. Root of 1800 whole square. This is this 1800. What value this is? 30 centimeter, because they given very clearly this is centimeters. Centimeters means you have to convert into root 1800 into, okay, that is 10 power minus 4 meters. This is the whole square. Yes or no? 30, that is 30 into 10 power minus 2 whole square means 900 into 10 power minus 4 plus 900 into 10 power minus 4. That becomes this in terms of meters, because all must be calculated in same units. Now if you calculate this one, what is you are going to get EP value? That is 9 into 10 power 9 into 8 into 10 power minus 9 by root square cancel, that is you are going to get 1800 into 10 power minus 4 here. So this is 10 power plus 9 minus 9 get cancelled, and you can calculate here 2 zeros minus 2 here, and 9 2s are, and this is 2 4s are, I can cancel. So what you are going to get minus 2, if you make it upwards, it becomes 400. It becomes 400. So that I can write as this. So electric field intensity at that point you got as 400. But this electric field is two-dimensional electric field. They are asking in terms of Ij. So because only one option is there, 8000, we did not got 8000. So we can't conclude this one. So in terms of I and J, if you want to write electric field at that point, it is a combination of electric field along x-axis, that is I cap, along y-axis, that is J cap. So what is x component? That you have to know that x component is equal to, that is E cos theta I cap plus E sin theta, that is E sin theta j cap. So what is E value? That is already we got, that is 400 into cos 45 degrees I cap, because theta is equal to 45 already got, plus 400 into, okay, that is sin 400 into sin 45 degrees j cap. But answer is given 400 root 2 I plus j form is given, or 4000. So here we got second option is not correct anyway, first option also not correct. 400 root 2. What is cos 45? 1 by root 2. This is 400 into 1 by root 2 means this 400 by root 2 I cap plus 400 by sin 45 also 1 by root 2, that is root 2 j cap. So if you solve this one, what do you get? Because third option, fourth option also not correct, because they given into, but we got divided. So in the form of third option to get it, so EP is equal to 400, can I take it as 200 into 2 by root 2 I cap plus 200 into 2 by root 2 j cap. So if you taken like that, what I can write, that is EP is equal to 2 by root 2, nothing but root 2, 2 by root 2, nothing but root 2. You make it upwards. So if you taken common, 200 root 2, if you taken common, we have already I cap plus this is j cap. So what is the answer in terms of vector? So electric field intensity at that point is equal to 200 root 2 I plus j, okay, is the answer for question. What are the units of this one? That is Newton per coulomb. It is a vector based expression. That's the next topic. We are going to discuss about electric dipole, and further discussion will be done after the completion of the topic.